It is February 28th, 2022, and this is the Monday Yaskawa VFD training class. And the subject today is some strategies for these difficult times. So, I talked a little bit about some of the current conditions. Our bookings continue to go up. It's amazing. And shipments continue to be down and unpredictable. And our manufacturing costs have increased significantly. And as you know, last year we put a 7% surcharge, and it wasn't a permanent price increase. This was a little bit different from our other competitors. And I want to make a note here in that, in my experience in industrial electric automation products in the United States, the sales department could depend on a 2 to 3 to 5% boost in their revenue every year, because it was traditional, and it still is traditional in some cases, for American companies to raise their prices. Now, we have all lived through a remarkable period of low inflation over the last 15 years, whatever. That's ending, and the inflation rate on the horizon is significantly greater than what we've seen in previous years. So I think that's going to happen even more so now. Yaskawa, since I've been involved with them, which is 1987, has never had a price increase on existing product. We do increase the price on products that go to legacy for obvious reasons, and we've had some price increases on buyout items. We private label Black Max motors. Those products go up in price regularly because of the price increases we get from Marathon. But on our own product, VFDs and servos, we have not had a price increase. And thus the reluctance to do so when faced with significant cost increases. For example, we were running, as of September of last year, $5 million over budget on shipments alone, inbound shipments. And we had to find a way to pass those costs on, or we were going to go into the red. So this 7% surcharge came out, and it was specifically announced by Mark Bernanke, the drives group leader, that we would roll this back as soon as things went back to normal. Well, okay, nobody knows when things are going to go back to normal. And I would counsel you to expect probably another price increase from Yaskawa, or price increase or increase in the surcharge sometime this year. I don't know that it's going to be as significant as the rest of the community seems. Yaskawa seems to be doing their best to absorb a lot of this, but I don't see costs coming down. The unfortunate price increase by default of the exit of the J1000 from the marketplace is unfortunately a price increase. There's no way around it. So what we are also seeing now is our finished goods inventory, which we would brag about a lot, is pretty much depleted, and we're going hand to mouth like everybody else at this point. The deliveries on drives as of today are out to May 9th, I think, is what you get when it's not on the shelf. And the deliveries on configured products are running 12 to 16 weeks. There's a bit more complication in terms of the configured product lead times, because not only do we have to deal with the availability of the basic drive coming out of our Buffalo Grove facility getting shipped up to our Oak Creek, Wisconsin facility for incorporation into the configured product, but we then have to deal with the availability of every other component that comprises that configured product. The sheet metal for our enclosures. As you know, we don't buy enclosures, we buy sheet metal. and we assemble our own enclosures, and our designs are such that they are UL 508, or now the new UL rating. The breakers, molded case circuit breakers, I'm sure you've all found that that's a very, very difficult thing to get in many cases. But we're having issues with all the other stuff too, power supplies, terminal blocks, whatever. And so the deliveries, I'm going to tell you straight up, when you get a delivery from us, it's not cast in stone. You have to deal with that because there's no way for us to predict an accurate delivery. I have no idea whether the 12-week delivery that you get today on a 200 horsepower NEMA 3R configured product is real. And the pause is for effect because I want that to sink in. It's just not realistic to expect that with what's going on, any manufacturer at this point can give you reliable lead times. So you're going to have to deal with that in your business strategies. When we have situations where we absolutely need to help the customer, that's what this session is for today. I'm going to tell you right up front that if you've got inventory, you are the king, and you can't put enough inventory in right now with what's coming down the pike. The customer base doesn't care about price as much as they used to. In fact, in most cases, they don't even care about it. They have a $10,000 an hour line down, and they need the drive. And if you have it, you're their huckleberry. So I can't emphasize enough that you increase your inventory because you're our best defense against dissatisfied customers. Our channel is extremely important in helping Yaskawa keep the customer base happy during these difficult times. By the way, I encourage you, when you do have situations, to call me and I will check with the other distributors to see what they have available. And I wouldn't expect that the normal distributor price plus 15% is going to be, courtesy transfer price is going to be honored at this point. No distributor is going to want to give up their inventory for a 15% gross margin, but you might be able to get something that will help you out. Control Concepts has a significant inventory. Motion Industries has a significant inventory. Some of our other channels are beginning to build up their inventory levels. And as a result, we're able to help each other out, albeit not with the courtesy pricing that we've had traditionally. Now, I'm finding that there are a lot of customers that are quite understanding of the situation, and in many cases it's a complicated multi-component availability issue, and we're usually not the pacing item, or at least there's something to take some of the pressure off of us. But there are those customers that are just irate and have either a legitimate or non-legitimate excuse for being irate. I try to take the non-legitimate guys and I give them Alan Bradley's phone number, and the legitimate guys I try to help out. So it is giving us a lot of opportunity for converting new customers, but as Mr. Bernicke says, we're not really in the business of getting new customers these days. We're in the business of keeping our existing customers. And so I don't really know what to say to you there. My confusion is obvious, and as a salesperson, my job is to get new business. But right now, I think that new customer discussions are I take them on tentatively, and I take them on with a desire to establish the sincerity. Because if it's a customer who's coming to me just because he can't get his normal drive and I know he's going to go back to it, couple of packaging firms, for example, came to me. They're Allen Bradley down to their underwear, and they want drives. And no, I'm not going to take drives away from my existing customers for somebody who's going to go right back to Allen Bradley when everything calms down. But there are customers who have a sincere desire to establish a long-term relationship with us, and I highly suggest that you have that frame set in mind when you evaluate new opportunities. The pricing policy, we've talked about this, so I'm not going to go over that anymore. I'm going to tell you that, notwithstanding the fact that we don't want to price gouge, don't give things away, because this is not a time when you need to undervalue your inventory. You need to be rewarded for the fact that you've put inventory in, and you need to be rewarded for and compensated for the extra effort that you have to go through to find a drive on a normal 100 horsepower sale. It's taking 3 or 4 times the manpower to conclude business on issues where on circumstances and opportunities where you don't have the ability to just click the button and order the drive. I call this the year of running in circles, because most of my day is running around trying to find stuff. Now, I think this is a great time to permanently take business away from the low-cost alternatives and some of the weaker European brands. Delta is the Asian low-cost company that I like to target in these times, and I target all the German guys that are or the European guys that are coming in with, shall we say, minor market share products. I also target Fuji and Mitsubishi customers, because those customers, once they change to us, I don't think they're going to go back. I am not targeting Allen Bradley customers. And as far as ABB, Danfoss, some of our bigger competitors are concerned, I take those on a case-by-case basis, because, again, it's that sincerity factor. And whether I'm going to take the valuable resources that I have and give them to somebody who's going to throw me out the door once ABB gets their products back in line. Now, on the point of ABB, the ABB 300 series drive apparently uses the same chip as the 500 and the 800 series drive. And if you've not heard this already, ABB really isn't selling the 300 series drive anymore, because those chips are being allocated to the more expensive, higher revenue producing products in the 500 and 800 series. So their micro drive, the drive that basically competes with the J1000, V1000, and lesser demanding GA500 applications, isn't a factor. You can't get it. The ACS 500 series and their ACS 800 series, which kind of overlap with the top end of the capability of the GA500 and then squarely compete against the GA800 from Yaskawa. Those products are what they're focusing on, and for good reason. I mean, I can see that. We don't have the same issue, so except we lost the J1000, but we don't have the same issue in that we don't have to divert business away from GA500. So again, that's something to be aware of. The opportunities that you're going to get from customers moving away from the ABB 300 series drive may be more genuine and may be longer lasting than we might think. So again, this is sort of my again, here I'm going to disagree with this. This is the way I felt in December. I would only go after the ABB 300 series stuff. but I should have added in here, always attack the German stuff, the lesser German, lesser European brands. Now, here's a point that I want to make to you, in that because Yaskawa manufactures everything and has manufactured everything that we make in terms of variable frequency drives, we don't have any private label history in terms of what we offer under the Yaskawa brand. It means that all of our drives are relatively interchangeable. And today, if you have an application for a simple, let's just say 25 horsepower pump, you would normally go to either a P1000 or a GA500 today. GA500 obviously is the successor of the V1000, so if you can find one of those, that's fine too. You could use A1000, you could use GA800. And theoretically, if the application is not too severe, you could actually use an HVAC product from the Z1000 product line, or whatever the new HV600 or whatever the new HVAC product is. My point is that Yaskawa drives, for the most of the applications, I'm going to say 70% of the applications, all the parameters are the same. For 70% of the applications, you're going to set up motor parameters in the E1s. Every drive we have has the same E1 parameters for basic AC induction motors. And the E2s, I should say E2s because the E1s are your volts hertz patterns, which are part of the motor setup. So the E1s and E2s in all of our products for 80% of the product lines, the same. C101 is always X cell, C102 is always D cell. B101 is where you determine the reference, speed reference source. B102 is where you determine the run stop source. These are all the same for all these products. So therefore, you can use pretty much any product interchangeably. The keypads, if you really get down to it, most of our keypads interchange as well. Now, not between 1000 and GA, but for example, the GA800 keypad, the LCD keypad works fine on the GA500, and in fact is an actual option. The interchangeability of these products is something I want you to be aware of because it gives you many more options. The other day, I was searching desperately for some 15 horsepower 460 volt drives, and we were out of GA500s. I went to V1000s, nothing. Couldn't find anything in the GA800 or A1000s. I found a U1000, but it was remarkably expensive and the customer wasn't going to go for that. What I did find that solved the problem was we use the V1000 for a product called IQ Micro, which is part of our IQ agricultural pumping products. And the IQ Micro usually sells in NEMA 4X configuration, so the drive-only IQ Micros, there's a bunch of them on the shelf. I found 50 V1000s with IQ Micro firmware on them in inventory. And thus was able to solve the problem for the customer. The customer is going to get what he believes is a 15 horsepower 460 volt micro drive. All I do is I go in and in the firmware and in the parameter and I shut off the IQ functions. Basically, I reinitiate the drive as an industrial drive. So my point is that when you're searching around with Yaskawa, you've got a lot more of these options. And these products interchange really well because of the consistency that we have over the years of our programming. Even if there's a Modbus serial interface and therefore any COM interface, and I'll explain that in a second, you have the ability to use other drives. I'm not asking you to memorize what I just said. What I'm thinking here is that it might be a good idea if you drop me a note and or drop anybody at Western Automation a note and say, hey, how can I get imaginative here? You know, the normal thing of I need a 15 horse drive, well, I'll take a 20 or a 25, even though if it's a little bit bigger, we can fit it in. Okay, everybody knows how to do that. But there were no 20s and 25s available in that situation either. We had to get really imaginative. And you may not be aware of all these other potentials. I certainly am. And therefore, I encourage you to call me when you need a drive, because I'll find a solution for you if it's available. In other words, I'm your avenue to exhaust the last possibility, shall we say. Okay, enough said about that. There are a lot of cases where we actually have the ability to size down, and I want you to keep that in mind. In order to use this tactic, I need to know a lot about the application, and I need full motor nameplate data. But there have been some cases where we were able to get the customer, and this is more in an end user situation. I'm not going to recommend this for an OEM, but we've had a lot of end users that, you know, the other day it was, I think it was an extruder, and the guy had a 200 horsepower drive on it, and when we got down to it, that line had changed, and he blew up the drive, and it actually wasn't our drive. But we were able to get him 150 and get the line running because he wasn't using the line for the originally designed capacity. There was a different product line on it now. So there again is the reason why I mentioned this slide. Sizing up, yeah. Again, that's kind of a default here. Now, I said I was going to come back to the COM card issue. All of our Modbus registers between the last two generations, and actually the last three, but the F7, G7, G5 series of drives is kind of gone. The Modbus registers are the same. So if I am going to substitute a GA800 into a GA500 to get the guy out of trouble, he's not going to have to completely reprogram his serial interface, because the parameters are the same and their Modbus registers are the same. Now, let's go back to this COM card thing. I want you to understand that all COM cards for Yaskawa are basically translators to Modbus RTU. The basic drive, its control board, the way it comes out of the factory, is with an RS-45 port for Modbus RTU protocol. There is no Ethernet port on our core control cards. Anytime you come into us with Ethernet, we translate that with a option card to Modbus RTU. The drive doesn't speak Ethernet. It doesn't speak at Ethernet speeds. It speaks at RS-45 speeds. So all of the protocol converters choke the data rate down to Modbus RTU bandwidth. This means that all COM cards are translators, and therefore the COM cards, when you switch drives around, you basically are going to be able to use the same COM card. Now, if you can't get the COM card, and that is an issue, then we go to somebody else's translator. As long as the protocol is converted to Modbus RTU, even if the board doesn't conveniently plug into CN5 on the control board of the VFD, but rather we hook it up through the RS-45 terminals, it's still going to work. You will still communicate. And therefore, I will give you a couple of options. The first one that I should do this because I'm the banner rep, or Western Automation is the banner rep. So this page here, which is the Banner Engineering products for Snap Signal. This is a product line from Banner that is dedicated to the IIoT, the Industrial Internet of Things. And I'm not going to get into that here. We'll probably do a session on this later on. But this bad boy here will convert. It's a converter card. You can see that the form factor is going to let you plug it into the control board of the drive, but it will allow you to convert protocols to Modbus RTU. Similarly with these products. So when you need a COM card and you can't find one, these are actually pretty much cost effective compared to our COM cards. I've said this in the past, we charge too much for our COM cards, but this is an option for you. The second option that I would refer you to is this company, Anybus. And there are probably a dozen other companies out there like Anybus. The reason I like the banner stuff is because the packaging. And Banner is a pretty solid company, and they've got a lot of this stuff in inventory right now. These guys have been spotty in their availabilities, but I've used them for years for protocol converters. And again, any bus to Modbus RTU is what you're looking for. So when you have a COM card issue, again, I encourage you to call us and we'll help you, even though this is, wandering out of Yaskawa's product line. I'll still help you because I want you to get the drive sale. But we're just talking about a protocol converter here. There's no magic to it. So for closed loop opportunities, it's the PGX3 card, and I know where a bunch of PGX3 cards are. So for 1, 2 type applications, again, give me a call. I'll be able to help you out there. We don't have a lot of options with regards to special software availability, because if you're using electronic line shaft, you're going to need an A1000, or as I announced a couple of weeks ago, the GA800 is now out with electronic line shaft. You can't swap GA500 in there or anything like that. So there you're basically in a tough spot. And in the cases where it's a really high downtime situation, we might be able to use DriveWorks EZ or a small PLC to help you out there. That's a very special case. And again, I would ask you to give me a call and I'll try to help you out in that situation. But, if you've got a big 500 horsepower extruder line down, it's all hands on deck and we need to find a solution. So, we still need to reach our goals. We still need to put bread and butter on the table. And I want you to understand that there are people available to help you do that. We have to be imaginative. And there are a bunch of us that can help you do that. So I encourage contact. I encourage you to use the human assets available to you to solve the problems. There are customers out there right now who may not have been willing to talk to you in the past, but as to put a final denouement on this, some of my best customers who I've been doing business with for decades came to me originally with a problem that I was able to solve when nobody else could solve it. And their appreciation for the effort and the technical expertise translated into a decades-long relationship. These kind of opportunities are out there right now. How do you find them? You just got to get out and talk to people. That's always our job, right? We're in sales. We want to find these opportunities because emotionally, this is how you win friends and influence people, to quote the old Dale Carnegie. And we don't want to lose those opportunities. It's going to be hard enough to get through these times. Right now, I think that that's one of the best ways to win business for the long term, is to save people now and to show them that we are the technical resource and we are worth the extra 10-12% over the cheap Chinese brand that they substituted us out for 5 years ago when everything was peachy. So enough said. I want to take some time to go through two documents that are extremely important to your understanding of the Yaskawa capability. These are not, well, first of all, that's not what I'm looking for. Okay, I'll start with this one. This is the selection guide, and apparently I mislabeled the GA500 selection guide, but we publish a data sheet on our drives, which is a little single-page flyer. We publish a bulletin, which is a multi-page document on the drive itself. But the selection guide is a better version of the bulletin in that there's more applications data in here on how to apply the different options on the drive. So I've actually gone to using the selection guide as my main tool in terms of hard copy literature, or what I send along with quotations, or what I send along via email in digital format to potential customers and to existing customers. I like the selection guides because they're a bit more applications oriented and they include a lot more of the data. For example, Watts loss. When designing a cabinet, and if you can't stand our 12 to 16 week maybe delivery on our configured products, right now you're looking at doing your own cabinets. Watts loss data is available. I have somebody's always asking me about what circuit breaker to use with the drive. Now, I know a lot of you have attended the short circuit protection class that we had a couple of weeks ago. But here's our recommendation for short circuit protection for each drive in the GA800. And by the way, the GA500 platform or selection guide has the same thing. So, drive derating. Here is where you can get the full product line single phase capability. As you know, we offer single phase rated drives in the GA500 product. They are, I think, available up to 3 or 5 horsepower. But did you know that every Yaskawa drive, even the GA800s, as you can see here, has a single phase rating? Therefore, you could use a 200 horsepower drive with a single phase source. Now, it's going to derate down to something like 40 horsepower. Or conversely, if you have a single phase 200 horsepower application, you can find out what drive you're going to use. And in this case, as you can see, it's a huge freaking drive. It's the 4605, which is normally a 500 horsepower drive. But this data is available. Do people actually do single phase in those power levels? Yeah, absolutely. The ones that occur to me of memory are the guys in the potato fields in Idaho that are running giant pumps and they only want to run 2 lines out to the installation. Technically, is that the wisest thing? No, but that's a different story. So these selection guides are a great resource and they're much more interesting for the customer to read, in my opinion. I've had much better reception And intuitively, I feel that this guide doesn't get chucked in the can as often as the bulletin or the flyer does when I hand them out in hard copy, or deleted when I hand them out digitally. So let's just go over these guides quickly to show you what's in here. Obviously, the part number definition, and then here we get into our standard drives. Now, IP20 drives, this is the way we send them out, and you know that in order to comply to UL NEMA 1 requirements, you need to add a NEMA 1 kit on the bottom of the drive. That'll come up later. But there's your 230 and 460 volt stuff. GA800 is only available out to 600 horse. Above that, you got to go to the A1000 or the P1000, which are available up to 1200 amps. Again, development schedules are out the window right now, and I don't know when the replacement for the larger A1000/P1000s are coming out for GA800. So we'll continue to jump back and forth. But to my earlier point, it doesn't matter whether it says A1000 or GA800 on the cabinet, because it's functionally, it's the same drive. Now, I love the fact that we put dimensions in this selection guide, because we've been very inconsistent. For those of you that have been with us a while, we're really inconsistent as to where we put the dimensional data. And that has to do with a whole lot of internal politics at Yaskawa. But some product groups would put the dimension data in their technical manual. Others would put it in the price book, for crying out loud. And I never knew where to get them. These selection guides are part of this anti-siloing movement at Yaskawa, where all product groups now must comply to a standard that applies to all products. And therefore, we can find our dimensions in the selection guide. Now, I like these expandable menus here because they give us basically an active, an interactive, dynamically linked table of contents. So we tend to go by frames, and you can see in interchanging drives which drives come in the same frames. So for example, you have no consequence substituting a 125 for a 100 in the case of a normal duty GA800 when the 100 horsepower isn't available. Where do you find the frame data? That's a good question. I think there's a table. Never mind, it's right here. So here's where you find the frame data. Sorry about that. That was a minor brain blip. And then you get into the actual dimensions as well. Here, height, width, and depth. So drive specifications, this is something you're all aware of. And the only interesting thing here is that the drive derating here for single phase also applies to carrier frequency derating and altitude derating, which directly affect this specifications page that we just jumped off of, which I can't find again. So when I'm at the drive specification page, bear with me, we have our standard ratings and our standard temperature allowances. And when you go high in altitude or change the carrier frequency, or obviously change the power supply from single from three phase to single phase, you go down here to the derating tables. Now, I want to make a point about carrier frequency in that if we go back to the carrier frequency derate, you can see that we significantly derate as we go up to 15 kilohertz, which is our standard maximum carrier frequency. For those, I don't want to insult anybody here, but everybody knows that carrier frequency is the switching rate of the transistors. And I would always run the drive at 2 kilohertz carrier frequency. That's in C602 parameter, I think, whenever possible, because that gives you the maximum thermal output, thermal withstand on the drive, therefore your maximum current output. You start going above 2 kilohertz, you've got to derate that, and the derate can be pretty significant going to 15 kilohertz. As you can see, it's 3.2 amps down to 2.78 amps, but if we go to something more substantial, like a 100 horsepower drive, you go from 112 down to 78.4. And that's a significant derate. In these size drives, you can't even go to 12 and 15 kilohertz because the switching rate implies too many thermal losses. So please be aware of that. And again, that's part of the selection guide. So here are all our control and feedback options. I think that I've been doing a lot of applications lately where I'm using the drive as a data collection node. And it's won me quite some business. And I started doing it basically just to alleviate some of the costing in the PLC on hardwired systems, so that because I can add digital inputs and analog inputs and digital outputs and analog outputs to the drive, basically I'm not using those for any drive functionality. For example, I'll put the DI16 card onto the control board of a GA800, and I'm able to pull in 16 more digital inputs that I can report the status of up through the Modbus serial interface back to whatever host controller. And that host controller makes use of the data. Now we have to bear in mind the read rate on this interface, which is in terms of, it's not microseconds, it's in terms of 5-10 milliseconds, but that may be fast enough for certain types of I/O. So as long as that is, you can use the drive as a remote I/O device. Of late, it's become very valuable to me because I'm doing a lot of wireless linking of the drive to some host controller that is some distance away. And whether it is a radio link or a cellular link, the drive again acts as a data collection center. In pumping applications, for example, and this is something that would be very interesting discussion to have with anybody in the industrial pumping arena, where you've got a plant that's got, say, remote industrial water treatment, what have you. The ability to bring in other sensors into the VFD, again, not using them to control the motor, just passing the data through. Whether it's analog inputs, you've got an additional 2 analog inputs, an additional 3 analog inputs plus the 3 that you already have on the GA800. You can now take 6 sensors back to whatever host controller, and I'm doing it wirelessly. So I'm in the middle of a field, and I've got a bromine sensor and a salinity sensor, and these are all reporting back either 4 to 20 or 0 to 10 volt into the drive, and the drive is boosting it up via Modbus to the wireless converter that is then sending the data out on a cellular link to the internet. These are the kind of applications where we really win, because we're doing systems work here with the drive, and margins are not an issue, and competitive capability is certainly not as prolific as it is, or comparable as it is when we're just selling, one dumb shaft turner to another dumb shaft turner. So I want you to be aware of the fact that these I/O cards, in my opinion, are wholly underutilized as a capability adder for the Yaskawa product. We've already gone over our network communication options. For those of you that don't know, Mechatrol Link is Yaskawa's proprietary, and it's an independent organization. And there are actually some people that use Mechatrol Link in Asia, but it's not very common here. Okay, lots of keypad stuff going on because keypads are holding up drive orders, believe it or not. We have had some chip issues with keypads. To the point where we can't get certain LED keypads, and therefore it's holding up drives. And somebody came up with the bright idea of, well, okay, charge a little bit more and send the LCD keypad out. At least the customer can operate the drive. So I'm not going to get into the details of the interchangeability, but the keypads, it's amazing how many of our keypads communicate with other drives that they're not supposed to communicate with. I'm just going to put it that way. Again, that's something you need to refer back to us. But here we have a lot of accessories for the keypads. By the way, this is an interesting and useful reference. I never can remember whether it's a mini or a micro USB. But the cables for the interface on the drives are in this selection guide. Now, here are your adapters. This is the NEMA 1 adapter that mounts to the bottom of the drive so that you can mount the drive on the wall. And when you do that, referring back to our short circuit class, short circuit protection class, you must use fuses. You can't use an MCB. But that's the NEMA 1 kit for wall mounting the drive. We do not have a NEMA 12 wall mountable drive yet. And while it was promised, it's part of that development schedule delay. I think that Dan Foss and ABB stole a march on us on that product line. It's a very good product. It sells. Right now, when we have to go up against that, we have to stick our drive in a can. And we will come out with a NEMA 12 version of the at least the GA800 and the successor to the P1000. I don't know that we're going to come out with that on the GA500, but as far as the development schedule is concerned right now, who knows? Now, external heatsink adapters. There's a very important point to make here when you're designing your external heatsink extension. And this is how you get the heat of the drive out of the electronic section of the enclosure, and by sticking the heatsink out the back. On most of our drives, this bracket mounts at the bottom of the heatsink, and all you do is you unbolt it and you bring it up to the top of the heatsink so that you can extend the heatsink out the back. But in a lot of our products, our caps are exposed, our capacitors are exposed, so therefore it's not a NEMA 12 interface. So unless any particulate that is out on the heatsink is going to get into the drive. We have a separate drive version. It's not field retrofittable, but for example, a 100 horsepower GA800 with the normal external heatsink adapters versus the special version of that drive that has the NEMA 12 rated flange, and we call it a flange drive. You must order the flange drive if you want a NEMA 12 interface between the external heatsink chimney and the internal electronics section of your enclosure. And I think we detail that later. Or do we? Well, let's see. Let me just, I think that's up here in the drive section. Do we? Huh. I'll have to find that for you. I thought we had a separate section. There is a separate section for that. I'm gonna have to go back to the price book to note that. But please note that when you want to have a NEMA 12 heatsink extension, you've got to specify the drive as such. It's not a field retrofittable adapter. Okay, now with regards to harmonics, all of our drives above 40 horsepower have a DC bus choke, which is equivalent to a 3% AC input line reactor. And if you remember our harmonics class, a drive's naked diode bridge back to the line is going to have 70 to 80% harmonic content on it. That's bad. You put a 3% line reactor in front of a diode bridge and you drop your harmonics down to 30–40%. The DC bus choke is equivalent to that 3% line reactor. So on our larger drives, don't just add an AC line reactor on top of that, because then you're going to have close to 5.5% impedance, and you may not want that much impedance. That's a lot of wasted energy, by the way, 5% of your energy bill. So there are cases where we will use an AC reactor and a DC bus choke, but they are rare. I don't mess with 3% braking resistors. I pretty much go to 10% because the cost is nominal, and 10% handles most of my inertia deceleration applications. If you have a very specific requirement for regenerated energy and you suspect that the 10% braking resistor will not work, then Danny Peters, myself, Eric Hodges, we're all well versed in how to calculate that. And I, again, highly recommend you get in touch with us and we'll calculate it for you. It's not just a guess. And 60% of the time, the 10% braking resistor is going to work. In most deceleration applications, with the exception of centrifuges, they will work. But they won't work if you're doing a test stand and you're using the drive as a load. At that point, you're going to have to go to a very big resistor bank, or you're going to have to go to a regen solution. The R1000, I'm not going to talk about that too much because not too many people use it, but that is basically a dynamic braking package where there's no resistor. We just shove the power back on the line. The reason I don't like the R1000 is that it puts a tremendous amount of harmonics back on the line. It's not a clean power solution. So this product here, I want you to be aware of, because in the case, as you saw under the D-rating section of this selection guide, you have to really D-rate a drive to allow it to survive with a single-phase source. And as a quick technical note, the reason for that is that single-phase rectified creates a bunch more DC bus ripple, which exercises the capacitors thermally. And if you don't have enough capacitance, you basically blow up the capacitor. There's no overheat sensor on the capacitors. So it violates our fault trip before component failure design. Unfortunately, the single-phase converter is often a price advantageous solution, because if you look at the cost of upsizing the drive versus using the single-phase converter, in many cases the single-phase converter will be close, and at that point you can use a three-phase rated drive, not oversized, on the output of the single-phase converter. So in the case of a 100 horse being upsized to a 400 horse drive to handle single-phase input versus putting a 100 horsepower rated single-phase converter in front of a normal 100 horsepower drive, In those cases, in that case, the cost effectiveness typically will favor the single phase converter. The other advantage of the single phase converter is that it has very low harmonic impact on the line, whereas a single phase rectified drive, albeit a big 400 horse doing 100 horsepower duty, its harmonics are horrible. Those are our optional DC bus reactors up to 30 horsepower. As I said before, 40 and above, it's irrelevant because they come with the drive whether you like it or not. By the way, the DC bus choke is something that I would always make sure I have in the single phase applications. If you're going to use any of these drives in their single phase configuration, add the DC bus reactor. It helps a lot in terms of calming down that DC bus ripple and allowing the thermal load of, allowing the capacitors to handle the extra thermal load. It just reduces that DC bus ripple. So, these AC input line reactors, by the way, are MTE, any MTE, TCI. I mean, these are just commodities. So you can use any one, again, from an availability standpoint. I think Hammond makes some reactors. There's a bunch of other people that make reactors. If you're hung up and you can't get a reactor and it's holding up your drive sale, then obviously, branch out and find a different source. Output reactors are used on full voltage switching PWM drives to ameliorate the effects on the motor. And it's typically for long lead lengths. That's a whole separate subject, but here is where they're detailed. And the various enclosures that come with these things is also detailed in the selection guide. Again, I really like these selection guides because they give us a lot of data that isn't available in another source. So let's skip over that. All right, there's our dynamic braking options. Again, you've got resistors and transistor units, and the transistor units are built in on our product in 240 volt up to 50, up to 150 horsepower. How about that? Used to be 40 horsepower. So you don't need the transistor unit. All you need is the resistor for 230 volt. Let's see what we build them into on the 460 volt. On 460 volt, we build them in up to heavy duty 100, like normal duty 125. By the way, for those of you that aren't really sure about what we mean by normal duty, heavy duty means no impact loads. Nice, steady load. Heavy duty means lots of impact loads, where you're going to require some intermittent current to handle intermittent torque loading, but it doesn't last for a long time. So that's kind of the difference between normal duty, smooth and choppy load. As you can see, we build in the dynamic braking transistor all the way up to the 125/100 horsepower. Beyond that, you got to add the CDBR units. These CDBR units do not communicate with the control board, and all they are is a voltage sensing circuit that will start shunting the resistor across the DC bus of the drive. So they're basically a big light switch, and they use a transistor, an IGBT, to shunt the resistor across the DC bus, sucking energy out of the DC bus and bringing the voltage down. In 460 volt applications, the CDBR units, whether they're built in or external, start switching at 760 volts DC to prevent the DC bus from rising to the 820 volt DC overvolt strip level. There's a hysteresis in that when the DC bus drops to 730 volts, the switching on the transistor unit, whether it's built in or external, then ceases, and we stop shunting the resistor across the DC bus. So 760 on, 730 off, and hopefully you have enough resistance out there to absorb the wattage, and then the DC bus doesn't go up to 820 volts DC where it'll trip. again, as I said, 10% duty cycle is good for most dynamic deceleration of inertial loads, with the exception of centrifuges. If you have a roller coaster, for example, and you're going up and then you go down for a long period of time, those applications, you're going to start looking at 50% resistor solutions, which is a lot of wasted energy, or you're going to go to regen. Okay. Oh, I've run way over time. Let me finish this up. I'm almost done. Thank you for accommodating and staying with me. I'm almost done, actually. I think I am done. Yeah, we're done because we've already gone over the drive D rating. So that is the selection guide for the GA800. The selection guide for the GA500 is very similar. I'll post these up on the Teams location for you to download, but you can get them off the website as well. And hopefully that's been helpful. It's tough times, and we need to be imaginative, and we need to be more imaginative than our competition, because remember, as tough as the times are, this is still about putting bread on our table and not on the table of the competitor. It's about putting dollars in our children's university funds, not theirs. And that means we still have to be competitive. We still have to go out and win business. And whether we're winning business for the long term or the short term, I think today we're probably talking more about the long term. But there are significant and positive opportunities for increasing our market share and winning customers' hearts today, more so than there ever were. As an outside salesperson, and I consider myself to be a professional outside salesperson, even though I'm educated as a technical person, my career has been in sales. And I will tell you in conclusion today that there's no better time than now for an outside salesperson who really wants to go out and win business. We thrive on chaos and havoc. Think about that. If you are trying to go out and change things, and as a salesperson, you're trying to change customers to your products, steady state, steady as she goes, everything is good times are the most difficult times for us. Now is where we really can do our job, and where we really can have an effect, and where we really can win. Because outside salespeople, we love chaos and havoc. And I'm telling you, I haven't seen a more chaotic time than we're in right now. All I can say every morning when I get up is, what's next? So thrive, go out and win some business, and call me if I can help. Thank you for staying with me. It's 8:14 and time to go to work, and we'll see you next week.
Thanks, Pierce.
Have a great week.